term first, which is 15 here, and then multiply with the coefficient of x squared, which is 1, and then I place that quantity over here, that is at the corner of the wedge-shaped figure. After that, I place the coefficient of x, in this case it is 8, over here. Now I need to pick out two quantities of numbers so that the product of those numbers would give me the number 15, and the sum of those numbers would give me the quantity 8. Clearly, I know that when 5 is multiplied with 3, I would be able to get the number 15. When 5 is added with the number 3, I would be able to get the number 8. So having made those initial discoveries, let us proceed. Foremost, I retain the quantity x squared, followed by 5 with the coefficient as x, and then 3 with the coefficient of x. Of course, with the constant term 15 is retained. Now this is my group 1, this is my group 2. From group 1, I would be choosing x as my factor, and that would leave me with x positive 5, followed by this positive sign, and then between group 2, or I should say among group 2, I would be picking out 3 as my factor, and that would leave me with x positive 5. Now clearly I see the presence of x positive 5 as a factor, and hence I choose x positive 5 as my factor, and that would give me x as my first component, followed by this positive sign, and then 3. So this is my solution for the given problem. Now for question number D, as usual I draw the wedge-shaped figure. I take the constant term 9 and I multiply it with the coefficient of x squared, which is 1 in this case, and I place it at this corner. Then I draw a line and I place the coefficient of x, which is negative 6 in this case. Now I need to choose two numbers whose product would give me the number 9 and whose sum would give me the number negative 6. Clearly I know that negative 3 when multiplied with negative 3 would give me a positive 9. At the same time, negative 3 when added up with negative 3 would give me a negative 6. Having made that initial discovery, I start off by placing the quantity x squared, followed by negative 3x and the second negative 3x along with the constant term. Clearly x can be taken as a factor from component 1, so that would leave me with x negative 3. Then I retain the negative sign, taking 3 as a factor. The first component would be x. Since I need to get negative 9, my second component would be negative 3, because product of two negative 3's would ensure a positive 9. Clearly x negative 3 is a factor. I take it out. My first component in this case would be an x, followed by a negative 3. The final solution can however be rewritten as x negative 3 the whole squared, because we see a presence of an x negative 3 followed by another x negative 3. The product of these two components would give us x negative 3 raised to the power of the number 2.